Begin by understanding the difference between weathering and gradation, two fundamental processes shaping the Earth's surface. Weathering refers to the breaking and fragmentation of rocks, which remain in place. This process is driven by static sources of energy such as heat, pressure, humidity, and rainfall. It involves mechanical, chemical, and biological actions, and is considered a static process because the fragmented materials do not move from their original location. Weathering is a key factor in soil formation. In contrast, gradation is the process by which the Earth's surface attains a smooth profile through erosion, transportation, and deposition of materials. Gradation uses both static and dynamic sources of energy, including rivers, wind, glaciers, and sea waves. Here, rocks are not only broken but also moved and deposited elsewhere, leading to the formation of various landforms and landscapes. Next, let's compare degradation and aggradation, two processes closely related to gradation. Degradation involves the erosion and removal of Earth's materials, which reduces the height of landforms. This process exposes new surfaces and is mainly driven by weathering, erosion, and mass wasting. Aggradation, on the other hand, is the process of depositing eroded materials in lowlands and depressions, thereby increasing the height of landforms. Deposition is carried out by dynamic natural forces like rivers, wind, glaciers, and sea waves. While degradation uncovers new surfaces, aggradation covers the original land surface with new deposits. These processes work together to constantly reshape the Earth's surface, balancing erosion and deposition. Now let's differentiate between abrasion and attrition, two types of river erosion. Abrasion occurs when rock fragments carried by a river hit against the riverbed and walls, effectively eroding them. This process is very effective and leads to the formation of features like potholes and plunge pools, increasing the depth and width of river channels. Importantly, abrasion does not hinder the transportation of materials by the river. Attrition, however, happens when rock fragments collide with each other, reducing their size. This process is less effective than abrasion and results in the creation of sand, silt, and clay. Attrition can hinder the transportation of materials to some extent and may reduce the depth of river channels due to deposition. Moving on, let's distinguish between a gorge and a canyon. Both are narrow, deep valleys, but their formation and locations differ. A gorge is typically found in wet, high-fold mountain regions and is created in hard rock by significant downcutting of rivers. It resembles the letter V, and examples include the Royal Gorge of Arkansas. In contrast, a canyon forms in arid and semi-arid regions with soft rock, where perennial rivers cut deep valleys. Side cutting is limited due to lack of rainfall, and canyons often resemble the letter I. The Grand Canyon of the Colorado River is a classic example. These differences highlight how climate and rock type influence landform development. Let's now compare alluvial cones and alluvial fans, two depositional features formed by rivers. An alluvial cone forms when a river exits a mountainous region and enters a less steep area, depositing materials like pebbles and sand in a cone shape. The slope is steep and the height is greater than that of an alluvial fan. When water flows over these cones, the deposits spread out into a half circle, creating an alluvial fan. Alluvial fans have a gentler slope and lower height compared to cones, and their shape resembles a hand fan. These features are important for understanding sediment deposition in river systems. Cyclones and anticyclones are two contrasting atmospheric phenomena. A cyclone features low pressure at its center, with winds blowing inward, rising, and moving anticlockwise in the northern hemisphere. Cyclones bring warm winds, high wind velocity storms, and rainfall, but are usually short-lived and destructive. In contrast, an anticyclone has high pressure at the center, with winds blowing outward, descending, and moving clockwise in the northern hemisphere. Anticyclones bring cold winds, low wind velocity, and usually no rainfall. They last longer and are not destructive. Understanding these differences is crucial for weather forecasting and disaster management. Finally, let's look at the differences between satellite imageries and topographical maps. Satellite imageries are prepared from photos captured by satellite sensors, representing landforms as they appear in reality. They are modern, rely on advanced technology, and can easily capture images of difficult terrains. Reading satellite images requires special training, but they are quick to prepare and less expensive. Topographical maps, on the other hand, are created through field surveys and use conventional symbols to represent features. They are traditional, take more time and cost to prepare, and require knowledge of map symbols. While satellite images can be used for weather forecasting, topographical maps are mainly for studying regions.